Hi everyone, welcome to second day of DSC Europe 2024. I hope you had a fruitful day yesterday. I'm Anastasia and I will here as a tech support during the tutorial. I want to introduce you to our first tutors of the day, Cyril Kondratenko. I think I said that right. A solution architect at Nebius, and Mikhail Rozhkov, technical support manager at Nebius, and they will hold mastering RAG evolution with MLflow and open source LLMs in Nebius AI Studio. So enjoy.
Hello, everyone. Can you please add Cyril Kondratenko to this call, please? I don't see him in the list of panelists.
Okay. Yeah, I can see him. Just a second. Just give us a few minutes to fix this.
Okay. I think we can start. And I'm sure that Cyril will join us like in a couple of minutes. And let me introduce myself then and start with the presentation. And and here's the Cyril. Okay. So
hi guys.
Yeah, hello. We are ready. So my name is Mikhail Rozhkov. I am a technical product manager at Nebius, and I'm working on products for AI and ML developers to what you guys need to on our platform to build awesome AI applications. Yeah, and Cyril is the solutions architect. So please introduce yourself.
Oh yeah, thank you, Mikhail. My name is Cyril, and I'm solution architect at Nebius AI. And so usually I help our clients to use our platform and the cloud and adapt their solutions to our services. And today I will be showing some hands-on parts with how to use our managed MLflow solution to evaluate retrieval-augmented generation pipeline.
Yes, let's then start with some like conceptual part, and I'll share my screen, and then Cyril will continue with the technical part. Okay, I'm sharing my screen. I hope you can see it. Okay, so today we're going to talk about RAG evaluation and with using MLflow and open source LLM tools. And it's like we'll introduce like briefly the RAG application itself, and then how MLflow can help with it, and then we'll jump to the some technical part of it. So what is the RAG? I'm sure that most of you already know and built some of them. And so this is like pretty popular part in AI applications development, and pretty important, I would say, especially for large companies. that want to like build something useful as fast as possible and allow other people to use it. But when we are looking on the RAG as like some system that serve our users, our clients, so we need to be careful to make sure that everything works right. So if we'll like look on that, trying to understand what we want to like be sure at like RAG performance. So we of course want to be sure that users get correct responses, right? And if something goes wrong, we need to understand it as fast as possible and fix it. And because RAG system usually like pretty complex, so we need to see that the whole system works as expected, as well as the separate parts inside the RAG pipeline also works like as expected. And usually we're working with multiple data sets, multimodal data, and like different data sets trying to optimize RAG behavior, and also with multiple models, both for embedding parts and for generations. And this is also like add some complexity, and we need to be sure that we can track and understand how like all those different versions of models and data sets, how they affect the end users. So we need some system to track and aggregate the information about the performance of different parts, visualize and and use that information to understand the behavior and improve it. And we need some tools to collaborate with others, right? Because like we need to talk with field experts, with other AI engineers. So we need some tool to make it efficient. So if we'll like look inside the RAG pipeline, so there are two main parts that are critical for evaluation of the RAG performance is retrieval part and generative part. And we'll today focus on two of these parts. So how to and what can we evaluate? So for retrieval part, we need to evaluate how well we can find relevant documents in the RAG index, search index. And so here we can use like pretty standard metrics like recall precision and DCG at K. And for generation part, we need to evaluate how well LLM generates the answer. And like here are like a few different metrics that can be used. And we'll talk today about robustness as our like custom metric and other metrics that are built in MLflow library. So what is MLflow and why we can use it for and should use it for RAG evaluation? So MLflow is the industry standard for ML and MLOps. So starting like from, I don't know, a few years ago, like it was mainly used for machine learning experiments and model management. But last 2 years, the MLflow team adds a lot of specific features and integrations for LLM development, and like it boosts the usage and number of usage of this tool specifically for generative AI applications. So it's a pretty simple tool to use and pretty flexible, and there are a lot of integration with popular frameworks. So why do we need actually MLflow? So we want to track our training and evaluation pipelines with different metrics and be able to some kind of visualize and compare different models, different experiments. So we also want to track the data, right, to see that how model behave on different data sets and like track models itself. So inside MLflow, we can evaluate and keep different models and manage those models with the different like tags. So they can be easier to navigate, like which models we use and which models in the which stage. For example, those are for testing and those models are good for production use. So and when we are talking like with about MLflow as an open source or managed services as we provided at Nebius. So managed usually provides more not functionality, but it's much easier to use, and you don't need to care much about infrastructure and object storage. So all those stuff's already like prepared for you. So there are two main use cases and functionality inside MLflow. So it's an experiment tracking part, this one, and model registry. It's like two tools that provide some UI inside MLflow, and that allows us to track metrics for training and evaluation and manage models. Actually, there are like new functionality called prompt engineering and evaluation, and we'll talk about evaluation today. So let's say that tracking and evaluation are two main functionalities right now that we will focus today. So just to give you a brief overview, if you never used MLflow before, so how it looks like. So for experiment tracking and for any kind of metrics and parameters tracking for your AI applications, MLflow provides very simple API like functions, log metric, log params, or some autolog that works pretty good with popular frameworks. And like you just call those function inside your code, and MLflow client just pushed those metrics into MLflow tracking server and can visualize this as a nice, like in tabular way or in the way as a diagram that can track the updates of your metrics during some process, like training, for example. The model registry part is the place where we can store our models, manage model lifecycle, and use it actually to integrate in CI/CD pipelines, for example, for automated deployment of the models that we prepared. So the new part of that we'll talk about today is the using MLflow for LLM evaluation, and like for example, like LLM as a judge in MLflow, like a set of functionality inside MLflow Gen AI package provides some specific LLM-specific metrics like similarity, correctness, relevance that we can simply use with the different LLM models. Like by default, it's OpenAI, but you can also like use any custom models or open source models like deployed nearby. And today, Cyril will show how to use open source models hosted by Nebius AI Studio. So this is pretty simple and much cheaper than with like ChatGPT-4, for example. So like you can add custom LLM metrics. As we told like before that there are some set of metrics that MLflow provides you and they are built in, but you also can design your custom LLM metrics for inside MLflow and use it. So in our example, it will be a robustness, and Cyril will explain how it works, how you can design and use it inside your script. But this will give you some kind of flexibility, right? So you can decide which kind of metrics you need. You can design some metrics for your specific application and mix these metrics with built-in metrics. So at Nebius, we like provide MLflow as a managed service in our platform, and it's pretty easy to start, like to create new MLflow cluster just with a couple of fields and clicks, and like it's like ready to go. It's supports training, LLM evaluation, and inference pipelines. You don't need to spend time and effort for maintenance, for infrastructure, whatever. So just ready to go. It's secure. We have backups, support on our team. And if you want to run your training or fine tuning like pipelines with GPU. We have available GPU, and so you just run your scripts and use MLflow to track performance tracking of your training and evaluation jobs. So and also like all artifacts that you generate and store with MLflow, they will be kept in one place in object storage, and it will be easier for your team to manage them and find and use for production later. I guess that's it from my side, and we can jump into hands-on part with the Cyril. And if you have any questions regarding MLflow, like manage MLflow at Nebius, or you'll have any question like during the presentation, so please feel free to ask your question in the Q&A or in chat, and I'll try to help you like in parallel with the presentation from Cyril. That's it. Cyril, can you continue, please?
Yeah, sure. So yeah,
I'll stop
just
sharing,
please.
so you can continue on your side, okay?
Yes, please. Okay, so okay, now it should be working. Great. So here I will cover like the hands-on part. So where we will describe how you build the evaluation pipeline for RAG. And so we will let's just follow along. And so it's like this part will be structured as is. So first we will like as you imagined for like evaluating anything. First of all, we need to make to have a reference data set. So like which is very often the case when you make RAG applications for like your specific use case. You don't really have any like off-the-shelf data sets which could be used as a reference. So in this part, we will cover how you can actually make your own data sets, which you can further use for the evaluation of the RAG pipeline. So for this, like we will take like some hypothetical use case where we want to make a RAG application which uses like a database with articles of like on AI and NLP topics, and like which will be designed to answer users' question on these topics. So for this, we will use an off-the-shelf data set like from Hugging Face. So in this data set, basically you have some summaries of scientific papers from arXiv, and this will be used to create a vector database for RAG. So let's begin with explaining how we can actually generate the reference data set. So what we will do is that we will pick some documents from this data set, and we will ask an LLM, Llama 405B in our case, to generate question answer pairs, which will serve as reference for evaluation. So let's jump into the code. And here, like obviously, like all this code base will be shared after the tutorial, so you can play with it by yourself on your own time. So let's continue on making the evaluation data sets. So first of all, we will need to import the clients for LLM, and like we use like Mikhail said, we will use models hosted in AI Studio in Nebius AI. So in our case, we'll use Llama 405B, and all the models which are hosted in AI Studio, their API is OpenAI compliant, so we can just basically use LangChain client for OpenAI. Yeah, so here we have our Llama 405B, and yeah, it works. So the next step, in order to like Mikhail mentioned that we can also use open source LLMs as evaluators in MLflow. So for this, the important thing you need to keep in mind is that while MLflow provides you a default option of using OpenAI models, you can also use basically any open source or self-hosted model. For this, first of all, you need to create a local proxy server, which just serves to align the API of the model with the expected inputs from MLflow side. So we can just deploy what is called a deployment server from MLflow. It can be configured with we just create basically a YAML config file where we have OpenAI compatible endpoint, which we call which is a chat model endpoint. We call it AI Studio Chat. We will use, by the way, we'll use Qwen 2.572b instruct. It's a quite capable model and will do very well for the evaluation. And we just pass our API key with the endpoint, and I just deployed it here in the terminal. You can see, and it works. So let's continue along. Oh yeah, just to demonstrate you how to use it, how to integrate it in MLflow. Yeah, basically you deploy it with this command, and after that you need to import this thing, get deploy client, and just create a client with the address of your local server, and it will work. So let's continue on to preparation of the evaluation data sets. Like I said, we will use an off-the-shelf data set of which contains scientific article summaries. So basically, it's just the abstract of the scientific paper, which just gives us a short overview what is this article about, and it's actually provides us a quite good primary material for this sort of data set, because it's a short, condensed, and very succinct source of information, which will work very well for to generate questions and answers for a model. So what we do here is that we just load the data set and we get all the summaries from the data set. And after that, we will cut them in batches of 4 because, well, just to save some time, the model will it will work way faster if we just use batch generation. And to generate the QA pairs, we will just ask Llama 405B to generate a standalone QA pair. Like here, we just use this prompt. Yeah, your task is to write a standalone question and answer given the context, and we explain what rules it should follow and the output format. So we just use a LangChain to create a prompt template for it, and we create a small helper function which will help us to process the batched requests. As I explained previously, we just group the summaries in batches of 4. So let's do this. These are just some helper functions for us to keep track of our results. And after that, we can start generating our question answer pairs. So what we do is we generate our question answer pairs, and at the same time, we use the tracing capability of MLflow, because MLflow it has already present integrations with packages like LangChain and Llama Index, and it will actually trace the call of every component in your chain. So basically here we don't really have a chain, we just have a client. So basically it will just log input and output, the execution time. So now you can see it's generating, and I'll go into MLflow UI and show how it looks, the tracing part. So here we have MLflow UI, and here we have the current running experiment, and we just go into the traces part, and you can see all the traces of every generation request. So here, for example, if we click on this one, it's very simple. As you can see, we just have our chat OpenAI client, which we call, and we have input, like our prompt, like our system prompt and the user message where we give the context, we give the summary, the article summary, and we ask to generate question and answer. So yeah, you can see the output is the question is what type of QA data sets and to give the best user performance for few short and zero shot settings, and it gives you an answer which can be replied with this context. So let's go take a look. Maybe it already finished generating the data set. No, it's still going on, but that's no big deal. Let's just continue along. So once this generation is done, what we will need to do, so yeah, you have your QA pairs, but so far you can just only hope that they're sort of okay to do your evaluation. But to actually have a reference data set, you need to actually call it like golden QA pairs for you. You need to make sure that these questions and answers they're as close as perfect as you can get. So for this, we will have another round after generation to evaluate this question and answer pairs and to filter them based on some criteria. So as I mentioned earlier, we will use an LLM which is hosted in AI Studio to do the evaluation. So we just do this part, which is basically tells MLflow that you use this deployment to integrate it for LLM as a judge metrics, and we can use some already prepared metrics in MLflow GenAI package. Just for example, we have a relevance metric, and just to create it with this custom open source LLM, we just pass the name of our deployment endpoint, which we specified here. That you see, we gave this endpoint the name AI Studio Chat, and we basically just pass it here. And this metric will use this endpoint for like to power like we'll use this LLM to power this metric. After this, we have some custom metrics which allow us to do a more fine-grained evaluation of this question-answer pairs. So we create this metric which is called groundedness. So basically, it allows us to tell how well grounded the question is in the provided context. So basically, if the question is corresponding to the provided context which we did during the generation part. And for this, we just provide two things. We give the definition of the metric and the grading prompt, because, well, as you know, what happens behind is just we just submit this prompt to the LLM with our inputs, and the LLM will give us the score. Actually, there's another thing you could do is you can also provide some examples. Like if we take a look in the MLflow documentation here, you have this part where we use LLM as a judge in this GenAI metrics. And you can, like in this part, creating custom LLM evaluation metric, you can actually create examples. So basically, this will be used as few shot examples for your LLM when you use it for evaluation. But in this case, we didn't do this, but that's something certainly you could do, and it will help to get more consistent scores in your applications. So here we define two metrics, like I said, groundedness and standalone. This is a very, very important metric. So because it actually stems out from the generation process of QA pairs, because what we do is we give the LLM, Llama 405B in our case, the summary, and we ask it to generate question and answer pairs. And sometimes what it does is that it will generate a question, but it will actually reference the context in the question. Like if we give some context, like about, I don't know, a data set which serves to evaluate some natural language inference task, for example, it will generate a question sort of like, what is this data set about? And like, it doesn't work as a standalone question, right? Because to understand this question, you actually need to look at the context. And this means it can't really be used as a question for evaluating your RAG pipeline, because the whole point of RAG pipeline is that you just give the question and it will find the context by itself. So, and this is a very crucial metric, actually, and something you should pay attention to when you prepare your evaluation data set. So here we just define these metrics. And after that, we go to the evaluation part. So what we will do here is actually we will use this MLflow evaluate function, which is just a high-level API from MLflow, which just allows you to put these metrics which we defined earlier and evaluate either a model or a static data set. And in this case, we will evaluate a static data set because we don't really care about the whole generation process, like how long did it take, because it's something we will do only once. So in this case, you can see we just create a data set for MLflow to evaluate. Something you need to keep in mind as well is that underneath, MLflow operates with data frames, with pandas data frames. And when you prepare your inputs, you should always keep in mind that every parameter you give to your metric will be expected as a data frame column in your data set. So here what we do is we just give our context, and we give the generated questions and answers for the model to evaluate, and we also give some additional data, because this data set we're going to save it later to use in the next part where we evaluate the RAG pipeline. So when we run this, let's do it. So what happens is that MLflow will just use this data set and will iterate these metrics over this data set. And it will take about a minute to run. Let's let it finish. And once it's done, we'll just go in the UI and see what does it look like. So yeah, if you well, I think we can actually already go there and take a look at it. So here you can see we have this evaluation run, which is basically what is going on right now. Sorry, it's doing this evaluation, and you can see we have the name of our run, and we just click on it, and it will actually give us the metrics which it measured, which it will give you mean, variance, and you can actually define the metrics aggregation in the during the definition of your metric. So you can have mean, variance, you can have percentiles, and yeah, I think these are the most useful parts. And you can also show it in the UI, all of your all of your aggregations, like mean values, for example, here. Yes, but these are not very useful right now for us, because what we are going to do actually is we will filter our data set based on the metrics. So we can just download this artifact from MLflow server, because once it's done running this this evaluation, it will actually upload the results to your MLflow tracking server, and it doesn't keep it in your like in the memory on like in your notebook. So yeah, you see it downloads it from the MLflow server, and yeah, you have your results as a data frame. And after that, we're going to filter our results with this criteria. So basically, we are going to keep the QA pairs which score 4 or higher in groundedness, 4 or higher in relevance, and 5 or like 5. Oh, there's no higher than 5 in the standalone metrics. As I mentioned to you, it's very critical that the QA pairs which we generate, they are completely independent from the context. So let's take a look at this. So in the end, we only keep these QA pairs, and let's see how many do we have. Yeah, we generated 100 QA pairs, like with the Llama 405B, and after evaluation, we have only 22 of them which correspond to our set criteria of these scores. So let's just save it as a Hugging Face data set and proceed to the evaluation part. So the evaluation part will be split in two steps. So in the first one, we're going to evaluate. Well, first of all, after building the RAG pipeline, we're going to evaluate prompt templates, which we can use for this RAG pipeline, and we're going to evaluate them with the robustness metric, which basically allows us to gauge how well our pipeline, like mainly the LLM part of this pipeline, resists to any like off-topic behavior. And like as you imagine, we like in our prompt template, we give the mission statement to the LLM, like, yeah, your role is to reply to the questions related to NLP and AI and machine learning. And like but as you imagine, like in any real world application, the user basically could give anything. Once they understand that there's an LLM running in background, like a lot of people, they'll try to jailbreak it, or like just to use it for their own goals, or to just, or maybe just try to have fun with it. But anyway, your application should be resistant to this sort of misuse. So this is a pretty important step, is to evaluate how well like a model and your prompt template can resist user behavior, which is considered inappropriate for your use case. And once we're done with this step, we will pick a prompt template. And after that, we're going to dive deeper in more RAG specific metrics, like evaluating how factually correct and precise our answers, like which we get from the RAG pipeline. So just let's continue to this part of the evaluating the RAG pipeline. So just as before, we're going to import all of our like, LLM client, and also we will need embeddings, because like as you imagine, for a RAG with a vector store, we need to have an embedding model. And something which Mikhail didn't say, in Nebius AI Studio, we obviously have LLMs, but we also have embedding models. So you basically you have everything you need to build your own RAG pipeline with it. And for building our RAG pipeline, we just use a very basic example from LangChain. Like here we have our very basic prompt, like, yeah, your task is to answer user questions, and here's the context. And like the next user message is the question. And after that, we just put them all together in the chain. Like here we have our retriever, our prompt template, our LLM client, and it will parse the output as a string. But to build this pipeline, first we need to prepare our database. And what we're gonna do is we take the same data set as we used here, as we used in the beginning to generate the golden QAs. We're just going to take all the summaries again and just create a simple vector database with the help of face, and use it further down as a retriever. So you can see if it works. Yeah, let's take a look. Yeah, we just ask some basic question like about some data sets used in NLP. And we see that the retrieval part, it actually allows us to retrieve like the relevant document. So yeah, it works. And let's test the whole chain. Yeah, you see it replies us the question. So yeah, that's something not surprising. We expected to have this. And let's now continue to the evaluation part. So like, as you know, like in this pipeline, RAG pipeline, we have two main parts. We have the generator part and the retriever part. And the generator part, we're going to have two steps of evaluation. As I mentioned, first we're going to evaluate the prompt template. And after that, we will have some more RAG-specific metrics, which allow us to evaluate basically the correctness of the outputs of the pipeline. And after that, we're going to spend some time on evaluating the retriever part, which is basically like that the vector database, which I just showed you. So let's continue to evaluating the generator part. And as in the previous step, when we were generating the reference data set, we will use open source LLM to serve as a judge for our metrics. And we do this is we already did. We started this deployment server from MLflow, and we just define our metric, which is called robustness. So basically, it allows us to gauge how well the LLM resists adversarial or misleading prompts. And we give some criteria to the judge how they should score this score the generation, like, based on this criterion. And here we define 3 different prompt templates, and we start with a very basic one. Like, yeah, your task is just to answer user question, and that's all. Basically, we don't give any guidelines to the model. So how they should behave if user asks anything, like basically anything. And as you can imagine, the models with this prompt template are going to relatively low on the robustness metric. Basically, here we're just testing the intrinsic guardrails of the models, because, like, as you know, Meta's models like Llama they have some alignment done on them, and they are considerably like more resistant to any like sort of inappropriate prompts, and they will outright refuse to answer like any sort of unsafe or inappropriate requests. But if you know, for example, models from Mistral AI, they are way they say they're way less constrained in this department, and they don't undergo such treatment as Llama models, and usually it's kind of easy to coerce them to do like some stuff which not normally they should refuse to do. So here basically this first prompt we're going to evaluate how well the model in itself can resist these inappropriate prompts, and we have the second prompt template. Where we just describe what is the role of the system, and we give some rudimentary guidelines how they should how the model should handle the reply, and also the output format. That it should give us the source of the context which it received. So like in an attempt to ground the model a little bit more in the context. And finally, we have the last prompt template, which is the most advanced. And we give very elaborate guidelines on how the model should answer. And we also give some ideas to the model as how should it handle any sort of inappropriate requests from the users. And as you can imagine, this prompt will allow us to get the highest score in the robustness department. So, and for evaluating this misleading prompts, we will use this data set. It's an off-the-shelf data set which is hosted on Hugging Face. Let me show it to you. So basically, it's called Jailbreak Bench, and it sort of assembles any sort of inappropriate or like naughty prompts from users, and it has two splits. It's split in two parts. It has like a harmful split and a benign split. Like harmful is like where you have like some really nasty stuff, and benign is let's say it's a little bit less inappropriate, but it's still like off-topic prompts which we will use for our evaluation. So we just load this data set, and we use the benign split of this data set. Yeah, just for the sake of speed, we'll just take a small part of the data set, like 25 items. And as you can imagine, the metrics which we defined earlier, the robustness, it also needs to have some reference to have an idea how to score the model outputs. It needs a reference or how the ideal model output should look like. So here we also define some ideal model output, how we want our model to reply to any inappropriate request, like, yeah, your request does not relate to NLP research practices, please formulate and resubmit your request. Okay, and so here we just have two models to evaluate. We will use Llama 3.1 8 billion and Mistral Nemo construct, which is, if I'm not mistaken, it's 11 or 12 billion models, and we can say they're practically in the same class, like as you would expect, like performance-wise, and it's a pretty fair comparison, like to do it for these two models. So let's continue to our evaluation code. So just as in our previous step, like where we evaluated the reference data set, we will use the same high-level MLflow API, MLflow.evaluate. However, in this time we also want we don't want to evaluate the static data set. We want to evaluate the whole pipeline. So what we do in our case, we just wrap our RAG pipeline in this function here, predict. As you can see, yeah, we just have this whole function which serves to evaluate the RAG pipeline. And in this function, we will just invoke our RAG chain with the model inputs. And please note that this model input is in the format of pandas data frame, because this MLflow evaluate API, under the hood, it uses like pandas data frame, and that's something you should always keep in mind, because you should just be aware of the shape of the data your evaluation function uses. So basically what we do is we pass this wrapper function to MLflow evaluate. We pass our data set of evaluation. Something which we call the target parameter is just basically for some metrics we need to give the ground truth target, and like I mentioned here, like for this robustness, the target would be like this ideal sort of reply from the model. And like for the MLflow evaluate function, this is just the name of the column which contains this ground truth items. We define our metrics, and we also can define any custom artifact we want. And in our case, we will put the prompt template into the custom artifact, which will be kept on the MLflow server. I will show it later in UI. And here is just the configuration for the evaluator. Sorry. So here, let's proceed to the evaluation part. Here we have our prompts to evaluate, like as we defined them prior, and we will just loop over our models, like over these two models in our case. And for each model, we will recreate a RAG pipeline with this model, and recreate the prompt template with our prompt. So we have 2 models and 3 prompt templates. We will have 6 evaluation runs. And after that, we call this this evaluate generator RAG function, which we defined here. And all of this we're going to wrap inside of an MLflow run, which you can just provide your custom names for this run. It's just for you to keep track of your results and to organize them in the UI. So we're going to just name our runs like with the prompt name and with the model name, and tag them with model and prompt, and like provide some short description. And let's go take a look at this evaluation. I'm not going to run it because, well, it takes a bit of time, as you can imagine, and time is precious for us right now. Let's go take a look at the evaluation. So here, as you can see, we have 2 of our models. We grouped each run, which corresponds to each prompt, to the corresponding model. So we have 3 runs for Llama 8B and 3 runs for Mistral Nemo. And let's take a look at the metrics results. So as you can see, you can organize these results in a very convenient way in the MLflow UI. You can tag, like we tag them with models, with the model name, and with the prompt. and we can see the results of the robustness evaluation. And as you can imagine, like the first prompt template, which is very basic scores, gets the lowest score, and the third prompt template gets the higher score. And actually, there's also another way of visualizing it. MLflow provides you a dashboard which you can use to evaluate to visualize your evaluation results. And we can see here in the legend, like which color corresponds to which run. So here on the bottom we have Llama 8B, and here on the top we have Mistral Nemo model. And if we go to if we click on the run itself, we can also find our prompt template in the custom artifacts. As you can see, you have the prompt template which we saved here. So this is something like which you can consider really convenient, especially if you have a lot of models to evaluate and a lot of prompts. It just really it's a really nice way for you to keep all your results in one single place. And here, like I can show you an example. I did this for 6 models, and as you can imagine, it would be a real headache to keep it organized. Otherwise, if we didn't use MLflow for it, basically. So let's continue with our evaluation. Yeah, like looking at your stuff in some web UI is nice, but there's also obviously you can download this results in your notebook and trace them by yourself if you really want. So once this evaluation function, this MLflow eval, finish this run, we will have the results object, but it's not actually the evaluation results, because the results they're stored on the tracking server. This is a link to this results in the evaluation to the evaluation results on the tracking server. And once we obtain these results, they will have to be downloaded from the server. So basically, even if you close this notebook, you don't lose these results. You don't have to rerun your evaluation. You can basically retrieve them later if you know the ID of your experiment, which you can find in the UI. And so yeah, we download these results and we can just group them into a data frame. So here, like you have the same table as right now we saw in UI. And after that, you can do basically everything you want. You can, for example, like use any of your favorite libraries to trace them. So let's continue to the next step of the evaluation. So right now we evaluated this prompt templates, and after that we're going to pass to the evaluation of the LLMs themselves. With the selected prompt templates, well, we pick the third prompt template, which is not surprising because it scores the highest. So for this, we are going to recover the data set which we saved here at the very end. If you remember, once we filtered our data set, we saved it as a Hugging Face data set. We just load it here, and we have our data set. Like the document object, question, answer, and the corresponding context. And likewise in the evaluation data set creation, we're going to use some built-in metrics for faithfulness and correctness. And actually, you can find some more information of these metrics in the MLflow documentation. But basically, when you use these integrated metrics, you can just create them by providing your deployment, which we defined here. If you don't do this, it will use GPT-4 from OpenAI, but then you will have to give just your OpenAI API key as an environment variable. And there's also one thing you need to keep in mind is that these metrics sometimes they rely on additional inputs in your evaluation data set, in the data set which you want to evaluate, sorry. And faithfulness metric requires context because, well, faithfulness, as you know, it basically evaluates how faithful is the answer to the provided context. So basically, it evaluates how well the model is able to follow on the information which is provided in the retrieved context. And correctness metric will require the target to evaluate against, which is similar to the robustness metric. Like it will need ground truth. So basically, obviously, the model will need to know what is the correct answer to evaluate the produced answer, in regards to it. So we define our metrics here, and we will reuse the same evaluate generator RAG function which we defined earlier. And however, this time we will just use a single prompt template, like the most advanced prompt template, which gave us the highest score. And likewise, we're just going to iterate over the models which we want to evaluate. And every time we go into the new model, we just recreate our RAG chain with the new LLM. And we create a separate run for every model, which we will just call like model name, eval, and the date time of the evaluation time. And as I mentioned before, like these built-in metrics, they require some additional inputs. And there is this part which is called evaluator config. Basically, it's in the function ml.evaluate. MLflow.evaluate. You have to provide the column names which correspond to the expected values, because this function, as I mentioned, it operates on a pandas data frame and it expects certain columns to be present in this data frame, and which are inputs, the inputs for the predict function, predictions, which are the outputs of that function, and you will also need the ground truth and context because they're expected by faithfulness and correctness metrics. And just this evaluator config is basically just a dictionary which maps this expected column names to the actual names in our evaluation data set. So here I already ran this evaluation. Let's go take a look at how it looks in the Flow UI. So here we have these two runs which correspond to the evaluation of Llama and Nemo models. And please don't pay attention to this third one. We'll use it later. So basically, we can just visualize our metrics in here. This we won't need. Let's go to the correctness, faithfulness, and something I forgot to tell you, but we also use a third metric for evaluation, which is latency, because as you imagine, it could be very beneficial when you design your application with RAG is to measure how long does it actually take for the for you to get the result. So MLflow also has metric to measure latency, and which we just include to our metrics here. And like the most relevant aggregation, we will just pick the 19th percentile for this metric. And as you can see, the Nemo model outperforms Llama in terms of correctness and faithfulness. However, it didn't score so well on a robustness scale, as like if you can remember. But also the latency of this model seems to be higher than that of Llama, because as I told you, Nemo is a bit bigger than Llama, and it may also tend to generate longer responses, which factors in this higher latency. So let's continue to visualizing our results. Like just as before, you can download these evaluation results from the tracking server and like assemble them into your data frame with like just the scores, and you can basically plot them like this to have like sort of side-to-side comparison between these two models of how well they perform. So these are like these metric scores from 0 to 5. And you can also do the same for the 90th percentile of the latency. And basically, depending on your requirements of your application, you can find a compromise, like what kind of model you will pick. Like if the speed is really important to you, you can probably sometimes compromise the quality and just pick the model which produces the results faster than like a sort of more a bigger and heavier model. Or you can also factor in the cost as well. Like sometimes, like most often, bigger models, they tend to cost more per token than smaller models, and so model choice is always a compromise, as you can imagine. So there's also one thing I wanted to show you in this MLflow UI. Like if you remember, we had tracing enabled in the very beginning with like the automatic tracing with the LangChain integration in MLflow. And basically all of these inference steps, you can find the trace of them. So basically here we have the trace of our RAG chain, which has some default names, like they're called runnable sequence in LangChain. But basically you have the retriever step here and the generation step here, and you have the inputs and outputs from the whole chain. For the retriever, if you want, you can find what query was used to find the relevant documents. You can also find what exact text was passed into your model and what was the output of the model. And you also obviously have the timeline for like how long did it take to execute the chain. Like here we can see like the retrieval part took like 54 seconds and the generation part took 85 seconds. So this is something which can be very handy, like when you pass your evaluation, you're integrating your pipeline into the application, and you want to tune the performance of your application or to debug it. This is something very useful. So let's continue on to the last part. Last but not least is to evaluate the retriever part, which is like in our case is the vector database. which we created in the very beginning with the data set of scientific papers abstracts. And what we will do is we will just create another static data set with the retrieved documents. This will only use the retrieval part of our RAG pipeline, and we will use our evaluation data set. Like we will use the question part, and we're just going to retrieve the document IDs which correspond to the question. And at the same time, we have the golden context. That's the context which served in the very beginning to generate this question. And for this, we can use entirely off-the-shelf metrics which are already present in MLflow, such as precision, recall, and DCG. And we just use this data set which we composed here with these metrics, and it's all very straightforward. And let's take a look at the evaluation run. So it's probably a bit easier to go back into the UI. Let's just make the relevant columns visible for us. Let's pick, for example, precision at 3 and recall at 3, and also at 1, just for comparison's sake. And as you can see, you can always use it for visualization of your metrics. Just this table. However, like when we have a large amount of metrics, like in this case, like we have basically with a varying k from 1 to 5, like k is just the number of retrieved documents if you didn't know. And like we have 15 metrics here. What we can actually do is like we just recover our evaluation results from the tracking server, and we can plot them as a function of k. So in our case here we have like it's a very simple sort of use case which we have here, where basically we can see that starting from like k over 2, there's not really point in like retrieving more documents. Like basically, like once we start to retrieve like 2 documents at a time, we already reach recall of 1. So basically, this would allow us to reduce the amount of the noise which we give to the LLM, and also because you should be mindful of the token count which you send to your LLM, also to save us some money on the inference. So basically, this wraps up this hands-on part, and like some stuff you should remember, like you should always keep in mind if you use MLflow for the evaluation, is that you need to keep in mind that it's an open source library, and you can basically tinker with it like in any way you want, and you shouldn't hesitate to dive deep in the documentation and source code, and like it will help you a lot to understand how it works. And I'm going to share this code at the end of the tutorial, and we actually have another version of this tutorial which is a bit more advanced. In that tutorial, we used another sort of way of evaluating LLMs with the Prometheus LLM. Like if you're not familiar with it, this is basically an open source LLM which is fine-tuned specifically to evaluate other LLMs, and it comes with its own library to evaluate LLMs, and in that code, we show how you can wrap any custom function as a metric for MLflow. So this we're going to show to share with you at the end of this tutorial. So I let maybe Mikhail take it from here, and we will be happy to answer any of your questions.
Yes, thank you very much. Yes, we have a few questions. Like, I think we can just we have some time and can let people to just ask the questions like in voice, right? So Jean Baptiste, if you'd like to talk, can you just like write in the chat, and I hope we'll add you to the panelist if it's possible.
I think we can just probably go like one by one in the chat. So
Okay, so
basically,
then the first question is about like what happens if we have like human written Q&A pairs? Do you see the way to map the Q&A pairs to the related chunks in the documents?
so this is something probably can be a little bit difficult to do if you just have QA pairs, because well, you could certainly try to do it with maybe just to match your question or answer like with semantic similarity to a context, but probably you will have to annotate them hand by hand in this case, and it's actually like if you're crafting a data set specifically for RAG evaluation, you can obviously do it by hand, but you always should start from the context. So you even like you use a LLM or you write QA pair by yourself, but the best way is to start from the context, because that's the cornerstone for this item of this evaluation data set.
Is there any MLflow functionality that can help with this in this task?
I think you could probably use the example metrics which we provided in the first part where we evaluated the data set, like just to have sort of baseline of your like for your prepared data set. But I think you don't really have to use MLflow for this. Basically, you can just use them like text embeddings to match the context with your handwritten questions or answers.
Okay, let's jump to another questions. Another question is about like best strategies to split documents, like in chunks, to make that to like cover the useful information and enough context to generate good embeddings.
So this is a very good question, because like at the very end of the hands-on part, I briefly showed you how to evaluate a retriever, and basically the only hyperparameter we modified was the K of the retriever, the number of the documents which you return from by the retriever. But you can probably just make several vector databases with different chunking strategy, and like use the same metrics like recall and precision to try to evaluate them. But certainly, like the chunking strategy, it could be another hyperparameter for you when you design your pipeline.
I think it's even possible like add this hyperparameter and track in MLflow parameters, right? And see it in the same table, same visualization, how this affect final metrics.
Yeah, you could probably tag your evaluation runs with like the chunking strategy you choose, or like you can tag like with maybe like with the size of the chunk if you want.
Yeah, yeah. Okay, go to another question. Is there a step where customer evaluation metrics are evaluated? How can we be sure that we can trust out metrics and we haven't made a mistake while defining them?
This is an excellent question because basically we like I can certainly understand why you ask this question because we use an LLM to evaluate another LLM, and I mean all the caveats which are I think intrinsic to LLMs they apply in this case. But what I would say is that it sort of became like de facto standard to use LLM as a judge for this kind of use cases, like when you want to evaluate RAG. And the choice of the LLM, the evaluator LLM, plays a big role. And like default choice for many sort of evaluation frameworks like RAGAS or DeepEval. I don't know if you're familiar with this. They use OpenAI models. If you want to go fully open source, you can use Prometheus. But yeah, the part where you define the metric itself is very important. It's basically before, like when we make our applications, we used to write like code, like for our applications. Now we write these prompts, and it's just as important, and it's probably even more important because it defines a lot how your LLM will behave. But I would say that it's that like MLflow doesn't give you like a good way, like straightforward way of evaluating the metric itself, but you could probably have like a data set like of examples of how like the score which you think corresponds to this metric. And I also mentioned in the beginning, but very briefly, that when you create a custom metric in MLflow, you can provide the examples. You can provide like few short examples. For example, like when we did we defined the robustness metric, you can actually provide the examples of like which corresponds to score 5, 4, 3, like up to 0, sorry, up to 1. And this will allow you to also to ground this evaluation a bit more in some concrete examples. But this is certainly a crucial part. You would spend a lot of time crafting the grading prompt.
Yeah, I also agree, and it seems the most robust way to ensure that your metrics like works well. Just to have this like separate data set specifically for this to test the metric itself. And I guess that the metric may like metric results that we design, if we design metrics in this way, they may behave differently on different LLMs. Is it correct, Cyril?
Yeah, certainly it is.
Yeah, so it makes sense then to have some kind of test data set for this specific metric and evaluate it against different LLMs if you want to use like new one, for example, in your applications.
Yeah, certainly. Like some models, they can be like overly critical. For example, like Prometheus, if you used it, it tends to like you need to be very precise in like what criteria corresponds to which score, because otherwise it will always tend to be very harsh. And you should also like keep in mind like that there is some bias in models. So for example, like if you evaluate your RAG pipeline, which uses GPT-4, and you use GPT-4 to evaluate it, like models, they tend to prefer their own generations outputs. And the best practice would be probably to use a completely separate evaluator, which you're not using in your application.
Cool. And the last question, I guess, how does all this works in context of multimodal RAG? For example, how would you go about retrieving images and text together, and how MLflow can use it? This is like for part from me, from myself.
So for the multimodal part, it can be quite challenging because as you imagine, well, you would start with you would have to start with the images, like with the data set which contains the images, and basically, well, you will have to use an evaluator LLM which is also able to process images. Well, I mean, if you go with a multimodal, like with a truly multimodal RAG, like when you not just do like captioning of the images, like with some like for example clip model, but I think it's certainly doable. Like if you just pay attention to like the model which you use for evaluation.
Okay, cool. Thank you very much. I don't see other questions. So guys, if you have some, please write in the chat, and this is the last call for the questions. If not, I think we can close this session, right? So we covered all topics that we had. We introduced the approaches to RAG evaluations and how MLflow can be used here. We showed how that the MLflow can be easily run on the Nebius platform, and for your evaluation pipelines, you can use Nebius AI Studio API with a lot of open source models. So, and if I remember correctly, like we had some kind of bonuses or free grants for new users. I'm not sure if they're still working, but yeah, I was happy to have one with my previously. So yeah, please just take a look and let us know if it works well. So here's like my LinkedIn, for example, and if you'll need slides, please let me know. I'll share them just after the tutorial. Otherwise, I think we'll share all materials like all together with all like conference materials. Yeah, and thank you very much for your attention and for your questions.
If anyone will have questions, thank you guys. This was very interesting. Thank you for taking your time to explain us this.